In previous video, we've talked about most common 6 DNS attacks. Let me remind you that there are more than 30 registered DNS attacks in the field of cybersecurity. And speaking of DNS attacks, it's impossible not to speak of DNS security. Because if there are attacks, there should be a way to protect us from these attacks. And that is what we will be discussing in this video today. To start with, we will look at most common secure DNS protocols that we can use to make DNS connections more secure. So do you remember DNS tunneling attack, where a DNS connection that is being led through the firewall is being used to pass the malicious data, malicious traffic to our network? In order to prevent those types of attacks, we need to use the secure version of DNS protocol. The first secure version of DNS protocol, remember that DNS runs over UDP. Right? And if DNS package is more than 512 kilobytes, it runs over TCP. So if you see UDP/TCP for DNS, don't get surprised, because there are cases when the package is more than 512 kilobytes, then it's running over TCP. But normally, as a rule of thumb, DNS uses UDP. It's a UDP protocol. So DNS can run over TLS in order to make it more secure. Shortly, it's referred as DOT, and it still runs through UDP, and TLS is running on top of UDP in order to ensure the security of communication. This is the first version of the secure DNS protocol. The second version is DNS over HTTPS. The principle is the same, right? It's still running over UDP. However, instead of TLS as a security layer, we're using the HTTPS. HTTPS is running on port 443, and this is the secure version of HTTP protocols that we know about. So we're using underlying HTTP version 1 or HTTP version 2. We're using one of the HTTP versions in order to establish the HTTPS connection under which the DNS is running. Shortly, it's referred as DOH. To be honest, since HTTPS and TLS are both secure, this is the matter of configuration and the matter of preference, ultimately, which one of these to choose. Next, we're going to review the Anycast DNS and Unicast DNS. Anycast and Unicast can come up in your interviews if you're being asked questions about DNS or IPs, so you better listen to this carefully. Realistically, the definitions are not difficult at all, where in Anycast, one client, let me do it in a more memorable way. Wow, my drawing skills are not good. The client, the end user, is connecting the server, the web server. We're trying to access google.com, for example. Traditionally, we would have the unicast type of connection. Unicast, you see? One-to-one. The browser would connect the server. There would be one server, one IP address behind the domain that we're trying to connect. One-to-one. In this case, disaster recovery is not as great, because if our server goes down, then that's it. We either should have the hot site to which we can migrate, or we have to have some prepared disaster recovery measures. So it's not great, and we have more latency. Because imagine that there is a DDoS attack aimed at this domain name server. So there is one bot, second bot, third bot, fourth bot, fifth bot, right? And they're bringing the server down. Since it's one-to-one, one DDoS attack and the server is down, we can't access it, more latency, more maintenance time, users are not happy, users are gonna switch to using yahoo.com or bing.com. So that's it. However, in order to not to be in this situation, Unicast DNS has been introduced. In Unicast DNS, which is shortly referred as one-to-many, one user, browser, is trying to access the web server. However, the web server behind the domain name, there is no one web server basically. There are multiple web servers that DNS protocol can refer our browser to. So for example, for us users, it doesn't make any difference, because we will get to google.com or whichever site we want to reach anyway. However, on the back end, it makes a lot of difference, Because in this case, it can use the load balancing. It can utilize the load balancing feature and distribute the load among these servers so that no one server takes all the load of the requests. It's harder to initiate DDoS attacks because imagine bot. They're all trying to access google.com. However, if the requests go first to server number 1, server number 2, server number 3, in this case, DDoS is not as easy to put together, for example, against Google, against Facebook, or any other website that uses the Anycast DNS. And it helps us to alleviate or even prevent DDoS attacks. That's why Anycast DNS is very common at the moment. Even if you do the dig on some websites, you can sort of realize that they're using Anycast DNS, where it is one to many instead of the Unicast DNS. You might take this topic further and do your own research to go deeper into this, because it's a very sort of common question on the interviews, and it's a very good definition or topic to be aware of. In which case, in case of the Anycast DNS, the disaster recovery is faster. One server went down, not a problem. We will give some time for it to fail over to another server. However, in the meantime, we're using the remaining servers. So we're fine with it. Lower latency, if there is, to start with, if we're utilizing the cloud technology, we have created these servers in different spots, in different locations around the world. So for example, all servers of the google.com don't have to be in the US. Some of these servers in Anycast DNS can be in Europe. Some of them can be in Asia. So that the users accessing it from Asia can be directed to servers located in Asia. And hence we get lower latency. And similar with European users. European users can be redirected to servers located in Europe. Also, we have lower latency because if there is a DDoS attack, it can be prevented or mitigated quickly. In which case also higher availability and lower latency. Long story short, if you can, go for Anycast DNS, because Unicast DNS is a traditional way of doing things and it's not as safe, as efficient and as popular as it was. Fifth topic that we're going to cover is the DNSSEC. DNSSEC is a separate protocol. It's short for DNS security. So the protocol's name is as you hear it, like DNSSEC. It's a very broad topic. It's a very new, relatively new, that came up to the market, and it's extensively used for the security of DNS records. So DNSSEC utilizes the signatures that are used and that are validated to make sure that DNS records that we want to access is the DNS records that we really need to access. Because a lot of cybersecurity attacks lately have been coming through the DNS's front, and it became really critical to ensure the security in DNS. Because through the DNS, first of all, firewalls can let the DNS connections through, and it can create the DNS tunneling. Using DNS, they can refer us to malicious website, and etc, etc. That's why signatures let us know if the domain that we're trying to access is legitimate, because we're looking at first of all, if the signature is valid, if it has not been expired, if the signature has been issued by the known certificate authority. So the signature issued by John Doe living at the address that we don't know about obviously is not going to be trusted, and only signatures issued by known certificate authorities, short for CA, are going to be accepted. DNSSEC utilizes the resource record sets. Resource record sets are nothing but a grouping of different domains or subdomains. So the grouping principle can be customized. I can't tell you that the domain names are grouped only by location. I can't tell you that domain names are grouped only by subdomains, because that wouldn't be quite correct, because the only word here, being more precise, is not correct. Resource records are used in order to attach and provide signatures for the single resource record. So imagine that we have small tennis balls. These are tennis balls, right? Some of them are blue, some of them are green, and some of them are red. I really hope you see it. So with resource record sets, Imagine that this is the different domain names. It can be example.com, google.com, it can be facebook.com, it can be bing.com, and another grouping can be by subdomains. For example, it can be maps.google.com, photos.google.com, it can be translate.google.com or drive. And similar logic for the third category. We have grouped our domains using the custom categories. And instead of providing signature for each of these domains, we provide one signature for the resource group. These groupings are called resource records. And we provide signature for the resource record instead of providing to each domain. This makes it easier with signatures, because imagine that we have to provide signature for each domain. Obviously, not every domain uses DNSSEC, but even if that would be the case, it would be so hard, so cumbersome to do all of this. For this reason, we provide one signature for each resource set, and resource sets are digitally signed. Please note that resource records RR is not used only within the DNSSEC. So we're looking at it within our DNSSEC topic. However, resource records is something that has been around with DNS for a long time now. However, DNSSEC protocol utilizes this. Please do feel free to explore DNSSEC in more detail. Whenever you try to buy a new domain name or set up your new domain with one of the domain providers, it can be GoDaddy, if I'm not mistaken, or Cloudflare, it gives you the opportunity to use the DNSSEC. However, you will be charged more for that because they have to provide signatures in order to make sure that the resource records are secure. Obviously, you have to pay more for that, or your trial period is usually shorter for DNSSEC, something along these lines. Don't forget to check out my video about most common cyber attack with DNS. See you later. Bye.